This video is sponsored by Hostinger. In this video, we're going to make a nice character controller in Unity 2D. It will be using physics, so we automatically collide with walls and can push around objects. We're also going to implement an instant dash and a sliding roll. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. Okay, so I've already done some videos covering simple character movement. However, in those videos, I covered it in the simplest way possible. So that means no physics at all. The character just moves by directly moving the transform. In order to find objects and collide with it, it does a raycast. So that's a great and simple way to move a character, but it has some limitations. For example, you cannot easily push objects around and interact naturally with other physics objects. So here we're going to make our character controller using physics. Alright, over here is our goal. There's our player character right here, and as you can see there's a bunch of debris on the floor. And if I go towards it, and there you go, I can push it around. Down here we also have an object simulating a door with a hinge, and if I go, and there you go, I can push and open it. So as you can see, we have some nice physics interactions. Since we were using a rigid body to move our player, we also have walls easily working. So over here there's this wall, and yep, there you go, I cannot go through it because it's a solid object. Now here we're also going to implement two nice movement features. So for example, we have an instant dash. So just like this, we can dash into any direction, and yep, there you go, the dash does not go through walls. And for another different movement type, we have a dodge roll, which instead of being instant, it simply slides along a certain direction. So I can go and slide around, and once again, it's all working with physics. So I cannot go through walls, but I can interact with other objects. Alright, so here is our character controller working nicely, which we can easily use as the base for any 2D game. You can expand upon this base to make some really cool abilities unique to your game. Share what you make with your friends by hosting the builds on your website, which you can get through Hostinger. Hostinger provides best-in-class hosting services that are extremely fast and very affordable with excellent customer support to help you succeed. Choose from a variety of plans and pick the one that best suits your needs. Making a website from scratch can be hard, but Hostinger makes this much easier by supporting WordPress. With just a few clicks, you can use the auto-installer to get WordPress installed on your website. Then you can pick from a giant selection of templates to quickly get started, and then customize the website to exactly as you want it. Here, for example, I have easily built a simple website by customizing a template. One excellent WordPress feature is how you have these buttons to swap between desktop, table, and phone displays, so you can rest assured that your website will look great on any device. Also, if you're making some really cool online integration for your game, then check out their super fast and affordable cloud hosting solutions. All the plans come with a 30-day money-back guarantee, so you can try out the services without any risk. Go to hostinger.com/codemonkey and use the coupon CODEMONKEY to get up to 91% off yearly web hosting plans. Click the link in the description and succeed faster. Using the link helps support the channel. So thank you to Hostinger, and also thank you to these awesome supporters for making this video possible. Go to patreon.com/unitycodemonkey to get some perks and help keep the videos free for everyone. Alright, so this is our goal. Let's get to it. Okay, so here we are in our starting scene. All I have is my character sitting around idle doing nothing. So I'm pressing keys and I cannot move him or do anything. Okay, so let's begin by making our character controller. So we make a new C# script, call it our character controller 2D. And now over here I have the player game object. As you can see, inside it has just a basic 2D light, a sprite for the shadow, and a object for the body. The body is composed of a mesh filter and a mesh renderer. So the animation system that I'm using is based on dynamically modifying meshes in runtime, so check the video in the description to see how it works. So this is the composition of the character, and then here I simply have the character base script which handles all the animations. So in here let's drag our newly created script, okay, there it is, and let's open it up. Okay, now in here let's start off by making our update function. And in here we're going to listen to key inputs. We're going to control our character using WASD. So if we have an input.getKey, in here we want getKey and not getKey down, since we want this to be true for as long as the key is held down. So we use getKey and then we choose, let's say, W. So if we press the W key, we want to move them up. And now just for starters, let's do it with the easiest way possible without any physics. So we just move the transform.position equals a vector up. So 0, 1, just like that. Alright, so as we're holding down the W key, we're going to move the transform up. Let's see. So here we are, and I press W, and there you go, he's moving up. Alright, so far so good. Now let's handle all the other directions. Alright, so I've copy-pasted the same code for all directions, and if we test, here we are, and move up. Yep, there you go, move down, move right, and move left. Alright, awesome. So here we have movement in all directions. Awesome. Now, so far, we're still working with moving the transform directly, meaning we are not working with physics. So back in the editor, if we try to make a wall, down here I have a simple wall sprite, so just drag it in there. So here is a basic wall sprite, and now in order to have physics, let's add a box collider 2D. And there you go, we have the collider. And now if we test, and here we are, and there's the character moving, and it can go through walls. Alright, so now let's implement physics on our character. Now the first thing we need is to have a collider. So here on the character, we select and we add a collider. And now in here we have a whole bunch of options. Whatever type you choose depends on your game. So for example, if you want to have smooth corners, you can go with either the circle collider or the capsule collider. But personally, I prefer to work with rectangles, so let's add a simple box collider 2D. So there it is, you can see the collider, and now we can edit in order to modify the size. And pretty much just like that. Now my animation system only runs when the game is running, so here all we can see is the shadow, but I can still guess the size of the character. And if we test, and there it is, with the game running, you can see that the box just pretty much fits the sprite. The sprite is built in a front top-down perspective, so rather than occupying the whole character, I'm only occupying the bottom part. Alright, so here we have our character working with a collider, but if we move, yep, there you go, we can still go through the wall. In order to get collisions to work, we need to add a rigid body. If you want to know more about collisions, check out the video linked in the description. Okay, now here on the character, let's add a rigid body 2D. And here in the settings, let's freeze the rotation since we don't want our sprite to rotate. And since we're working on top-down, let's also disable gravity by setting the scale to 0. Alright, so this is our setup. Now back in our code. In here, the first thing that we need is a reference to our rigid body. So let's grab it on our awake. Alright, we have our rigid body reference. And now here we have our update function, which gets called on every frame. And we're testing for when the keys are down. So now you could assume that we would simply change the rigid body for the transform. However, when working with physics, the physics system is running at a different rate than our actual update. So instead of the update, we should work with our physics inside of our fixed update. So it's in here that we should modify our rigid body. However, we still want our inputs to be nice and snappy, so we want to grab them in the normal update every frame. So the solution is to capture our inputs here, store them in a vector, and then use the vector down here. So all the way up here, let's make a private vector 3 for the move direction. And now here on update, let's set our move vector. So first let's define a float for the move x, start off at 0, then a float for the move y, start off at 0, then we set them in here. Alright, so we define a move x and a move y, and then we handle the keys. So for example, if we're holding down W, we set the move y to 1. And then down here, we construct our vector based on the move x and move y. And now here we need to remember to normalize our vector so we make sure that we don't go too fast whilst going in the diagonals. Alright, so we have our move direction. And then down here on our fixed update, this is where we can modify our rigid body. Now there are two ways we can modify the rigid body. We can use move positions. This function will move our rigid body from the current position onto the target position. However, this can lead to some jittery movement if you try to move to an invalid position, like say inside of a wall. So the other approach that I prefer to take, which is setting the velocity directly. So we just set the velocity to be the move direction. So this way we don't tell the rigid body specifically where to move to, but rather just in what direction it should move, and then the physics system decides if it can move in that direction. Alright, here's our rigid body setup. Now let's test. Alright, so here we are, and let's try to move, and yep, there you go. It's moving insanely slow, but yep, it is moving the rigid body. And if we move up and see what happens when we collide with the wall, and keep going up, keep going, keep going. And yep, there you go. As you can see, it reached the wall. I'm still pressing W, but it's no longer going through the wall. So just like this, we have collisions working automatically. Awesome. Now, as you might have noticed, the character is moving painfully slow, so let's fix that. Here in our script, let's define a nice constant for our movement speed. Alright, we have our move speed constant, and then down here, when we set the velocity, we set it to the move direction multiplied by our move speed. Okay, let's test. Here we are and try to move, and yep, there you go. Now we have a much more accurate speed. So if I go, yep, there you go, I cannot go through the wall no matter what I do. Alright, awesome. Now, one thing that you might also notice is that the movement is actually quite jittery. So look at that, it's very, very bad. So let's fix that. Here in the editor, we can see our rigid body, and down here we have the interpolate. So it's in here that we can set from none into interpolate. And if we run again, and here we move, and there you go, now the movement is actually perfectly smooth. So everything's being interpolated between each physics frame. All right, awesome. Now that we have the movement working, let's add some animations. Again, this step will depend heavily on whatever animation system you're using, but as always, remember to write clean code. So make sure your classes are as decoupled as they can be. Here in my case, the animations are all handled inside of this character-based class, and I don't care how the animations are implemented. All I care is that this class exposes some functions that I can use to play the various animations. So first I grab that component that handles the animations, so it's the character base. I get that component here on awake. And now when we set the move direction, I can call the function playMoveAnimation, which takes the movement direction. All right, that's it. Let's test. So here we are, and he's idle, and I move, and yep, there you go. Now we have our nice animations working. Again, this is going to depend on what animation system you're using, but the main point is remember to keep your code nice and clean. So in here, I don't care how the animation is implemented, as long as I have a nice function that I can pass in a move direction. So whatever this function does, I'm not interested whilst working on the character control. And this animation system is based upon dynamically modifying meshes in runtime. So here in the scene, you can see that the animation system is made up of dynamically modifying the meshes. I covered the basis for this system in another video, so check the link in the description if you want to know more. And with this, we now have a nice character moving around. Alright, so we have our basic character controller working. Now again, since we're working with physics, let's play around and add some debris. So over here I have some prefabs with a bunch of rocks. As you can see, they just have a different sprite and a box collider and a rigid body. So here they are, a whole bunch of rocks. And now if I test, so here we are, and I can move the character, and I can go, and yep, there you go, I can push around all of the rocks. Again, this is because we are using the physics system directly to move our character. So we don't need to do anything else in order to make it interact with other physics objects. And over here, I also have a simple door object. So it really just has a hinge and then another object. And again, if we test, here we are, and if we go and try to move, yep, there you go, I can push that object without doing anything else. All right, awesome. So here you can see our character and everything working correctly with physics. Now that we have the simple movement working, let's add some more features to our character control. First, let's add a simple dash. Our dash is going to be essentially an instant teleport, but without going through walls. So back in our code, in our update, let's test for pressing the spacebar. And here we are using getKeyDown since we only want this to be true on the exact frame that we press the spacebar. And again, on the update, we're only handling recording our inputs. And then on fixed update, we actually move our rigid body. So let's go all the way up here to store a simple boolean. Let's call it is-button-down. And now down here, if we have the getKeyDown on the space, then we simply set our is-button-down to true. And then on the fixed update, if the dash button is down, then here we want to move our rigid body. So in this case, instead of modifying the velocity, we're going to use the move position function. So this will move the rigid body towards the target position. So our target position will be based on the transform.position, which is our current position, plus the move direction, and then multiplied by a certain dash amount. So in here, a float for the dash amount, and then we use it in here. All right, so just like this, we are teleporting our object instantly towards this new position. And after we dash, we set is-button-down back into false. All right, so just like this, we are instantly moving our rigid body onto this new position. Let's test. Okay, here we are, and let's move and press space. And if there you go, we have our instant teleport working perfectly. So we press space and instantly teleport quite a bit ahead. All right, so here's our dash. However, we have an issue. Since we're setting the move position directly, there you go, we can now go through walls without actually colliding with them. So let's fix that. So let's do a simple raycast to validate our target position. So here we have our raycast. We do a raycast from our transform position towards the move direction by this dash amount. If it collides with something, we modify the dash point to be the exact point where the collision happened. However, if we just run like this, and now here we are and try to move, and yep, there you go, he's not actually dashing because he's colliding with the actual player hitbox. So we need to use a layer mask to define what we're going to hit. So for example, here on the wall, let's modify the layer and put it on the walls layer. And let's also make a objects layer. So for the wall, we set it on the walls layer, and down here on the hinge object, let's put this on the objects layer. All right, so we have everything on different layers. And now here we can pass in a layer mask into our raycast, and the layer mask is a Bitmask. If you're not familiar with Bitmasks, then check the links in the description. One way we can easily set this is to go up here, and we're going to add a serialized field for a layer mask. And this layer mask actually shows in the editor, so if we go back, and yep, here in the editor we can see a very nice drop-down menu for our layer masks, and in this case we want to collide with walls and with objects. So we select both of them, and now down here we can use our dash layer mask. Alright, so let's see now. So here we are and dash to the right, and yep, there you go, we have our dash, and we can dash through our rocks. However, if we try to dash through a wall, and there you go, it doesn't work. Alright, awesome. So now our dash actually works correctly and it does not go through solid objects. Alright, awesome. Now over here I also prepared a very simple dash effect. So it just has a sprite animator going through a bunch of sprites and then it destroys itself. And I can spawn it using this basic static function. So just to add a nice visual, let's use this. So in here when we do dash, then let's call that function. Alright, there it is, just like this, and test. Okay, here we are on dash, and there you go, we have our nice dash effect, and everything is working correctly. Alright, awesome. Okay, now for another move type, let's add a nice dodge roll. So instead of being an instant teleport, this is going to be a constant movement in one direction. And now here, in order to add that feature, we need to make a decision regarding how we're going to structure our code. So should the dodge roll be implemented inside of this character controller class, or should we make it as something separate? So that's going to depend on what type of game you're making and how you're structuring your code. Here in this case, I'm going to duplicate this class. So back in the editor, we just duplicate this script and let's call it the simple version. And now let's add the dodge roll implemented inside this. So I'm going to include both of these in the project file so you can use whatever best fits your game. Okay, now in order to do our dodge roll, it's actually quite simple. We're going to use the velocity field very much like we do when normal movement. Okay, so in here, let's put the dash on a different key. Let's put it on F. And then let's do a get key down on our keycode.space. Alright, so when we press space, we want to start our dodge roll. Now, the first thing we need is to store where we actually want to roll towards. So let's go up here to make another vector 3 for our roll direction. And now down here, when we press space, we set the roll direction to be our same move direction. Okay, there it is. And now the question is, how do we actually move towards our roll direction? As you might guess, we cannot simultaneously have normal movement working alongside with the roll direction. So for that, let's make a simple state machine. So up here we define a private enum, call it our state, and the state will either be normal or rolling. So then we store it in here. And on awake, we start off as normal. And then on our update, we do a switch on our state, and we only run this normal code in case we are state.normal. And when we are rolling, we simply ignore the inputs. Okay, so far so good. And now on the fixed update, we do this on switch on our state. If we are normal, then we do the same thing that we were doing previously. And if not, if we are rolling, then it's in here that we want to modify our rigid body velocity. Alright, so here it is, very simple, just using a basic state machine. Now so far, everything is following pretty much the same logic as the normal movement. Now the difference is that the roll speed is automatic and it should slow down. So let's also store that. So all the way up here, let's also store a float for the roll speed. And on our fixed update, we're going to move by the roll direction multiplied by the current roll speed. And on the update, whilst we are rolling, let's reduce the roll speed. Alright, so here we have it. On the fixed update, when we move the rigid body, we move it using the roll direction and the roll speed. And then in here, whilst we are on the rolling state, we're simply reducing the roll speed based on a certain multiplier and always lowering it by time.delta time. And if we go under a certain minimum, we simply reset the state back to normal. So the last thing that we need is to set our starting roll speed. So in here, when we set the move direction, we set the roll speed to the starting speed. So let's say this, and we also set the state into state.roll. All right, so here is our roll speed code. Now let's test. Okay, here we are, and we can still move, we can still push, everything's great. And if I press space, and there you go, we have a nice roll speed. So as you can see, it goes fast, then slows down, and after a while, there you go, it goes back into the normal state. All right, so here we have our dodge roll working great. Awesome. Now let's just add the animation. So here when we start rolling, let's once again go into the character base in order to play the roll animation. Again, how this is implemented does not matter for the character controller. All I care is that I have this function, so I pass in the roll direction, and then we test. Okay, so here we are, and I press space, and there you go, we have our nice roll animation, and now it looks like an actual proper roll. And if we press F, we still have the instant teleport. So instant teleport and a nice rolling movement. All right, awesome. Now finally, let's just fix one issue. So right now, if I'm not moving at all and I press the roll button, and there you go, nothing happens. He doesn't actually move anywhere. And the same thing if I press dash, and there you go, nothing happens. He is rolling, but he's not rolling anywhere because he's taking the roll direction as a vector 0. So here when we have our update and we calculate our move direction vector, if both these are 0, then we're going to have a roll direction as a vector 3, 0. So how we solve this is to make sure that when we roll or dash, we do it towards the last move direction. So let's define that up here. So we have the last move direction. And then here when we set the move direction, if the move X is not 0 or the move Y is not 0, then we are not idle. So here we can set the move direction to the move direction. Okay, so we have the last move direction, and then down here when we set the roll direction, instead of using the move direction, let's use the last move direction. Same thing down here on the space when we have our dash. Instead of using the move direction, let's use this last move direction. All right, let's test. Okay, here we are, and I can still move, I can still roll normally, dash normally. And now if I go and I stop, and now I press the roll button, and there you go, now he rolls onto the last move direction, and same thing for the space and the dash. All right, awesome. So just like this, we have a complete, fully working character controller. So you can see that we can move in any direction, everything is nicely animated. We cannot go through walls, so if we try to roll or we try to dash, nope, doesn't work. And we can push around other physics objects, so like this piece of debris and as well as this hinge joint. So here it is, a very, very nice character controller that you can use on just about any game. So thank you to Hostinger, and also thank you to these awesome supporters for making this video possible. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. As always, you can download the project files and utilities from UnityCodeMonkey.com. Subscribe to the channel for more Unity tutorials, post any questions you have in the comments, and I'll see you next time.